Well, thank you. It's a great honor and privilege to be here for the second time for the second Uber Elevate Summit. What I wanted to do today is talk a little bit about why autonomy is eating aviation. Okay, that is really our focus in this. You've heard a lot this morning about a lot of different elements. People have hinted at the importance of software in this. You've seen that the air traffic control system that Uber plans to deploy will be completely unmanned, and I wanted to share Aurora's vision of how the airplanes are equally unmanned in that. So this is where we were a year ago. This is the chart. This is sort of the wrap-up chart from our presentation a year ago. And as has been said many times this morning, a lot of different things have happened. Our big news during the year was that Aurora was acquired by Boeing. Why did Boeing do that? Clearly, the interest in urban mobility is a piece of that. Aurora works in a lot of different areas, from high-performance subsonic designs, very long endurance designs, and the urban mobility designs. But we think that the power of Boeing combined with the innovation of Aurora is a very strong combination that is focused on this urban mobility situation. And that's all I'm going to tell you about what's going on with us and Boeing. Let's talk about what we think is the key issue in this. This is a plot of the total number of pilots during the professional lifetime of most of the people in this room. And it's been a generally downward trend over time. You can see that these are the private pilot numbers, these are the commercial pilot numbers, these are the sport aviation numbers, those are the air transport pilot numbers. And this is in spite of a whole range of developments over the years that each time people said, oh, this is going to change the game. This is going to revitalize general aviation. This is going to make urban mobility possible. We've seen glass cockpits, fly-by-wire, the General Aviation Revitalization Act, ballistic recovery parachutes, parachutes on the airplanes, general aviation glass cockpits, a whole new light sport aircraft domain, 5 decades of technology development, and they haven't moved the needle on on-demand air transportation, and they haven't reversed the trend of downward participation, let's call it, in the air traffic system, a 40-year decline in the number of pilots. We can talk about why that is, but the point here really is there has been only one technology in 50 years that has actually moved the needle, and that's the drone revolution. This is what exponential growth really looks like. This is what changing the game really looks like. Those are the number of registered drone operators in the FAA database. And you can see it's the classic exponential off the chart. That's what a revolution looks like. And why is that? It's because of the autonomy, the automation of this that takes a complex task and simplifies it. That's what's made it possible to take what used to be the hardest thing in flying small airplanes and made it to where literally anybody can do it. Big aviation is today still stuck in the era of amateur radios, right? You used to have to learn Morse code, have an FCC license to operate a mobile radio. And now everybody in this room has at least one, and probably several of them, and they don't even come with instruction manuals. If you had to move from LA out to Ventura County and manually be handed off from one telephone operator manning a cell tower to another, nobody would be using these, okay? It's technology masking complexity that makes things work.
This is an old helicopter that flew in the Vietnam War, but now it's equipped with a high-tech autopilot system. The helicopter flight is controlled by a Marine on the ground using a tablet. He says it's easy.
Order an Uber, ordering a pizza. That simple.
Sergeant Deontay Jones says he doesn't know much about flying a helicopter, but he says it didn't take much training to accomplish this mission.
basically the same thing as calling an Uber. All you're going to go do is submit a new request, and you just press submit, and you're good to go. It comes right to you with the supplies that you need.
So you know you've made it when your name becomes a verb, right? Okay. But that video was a demonstration that Aurora did in December of 2017, so just a few months ago, with a program called ACUS, which was sponsored by the Office of Naval Research. Total program investment of $100 million or so in this to make it possible to add autonomy to aircraft so that literally anybody could operate them. These are the kinds of technologies that are in there, and the point of all of this is that Aurora is building certifiable autonomous systems that will enable all of tomorrow's intelligent aircraft of any shape. This is not a game. This is not a business about exactly what the airplane looks like. You saw there's 75 different innovations of airplanes, and maybe none of them are what will actually end up being deployed. What they need, though, to underneath is the certifiable autonomy. What you saw is some of the technology that goes into ACUS, the perception systems. This is a program we have called Centaur that takes an existing certified general aviation airplane, installs robotics in it, allows the robotics can fly the plane and do everything in the pilot operating handbook. So everything that a pilot is trained to do, this airplane can do on its own. This is a robot in a 737, okay? This is the same underlying autonomy core, now flying not a Vietnam helicopter, not a general aviation airplane, but a 737. Now, is this how it will actually be deployed? This is a robot flying a robot, right? This machine, it's a robot flying the standard 737 flight management system, okay? It's amazing. It's a little scary, actually, to watch this. But this is where we're headed in how these airplanes will operate. This is this is part of a program called the XV-24, a DARPA program. This is the subscale demonstrator. This is a distributed electric propulsion battery-powered eVTOL that is fully autonomous. This is what Mark Moore was talking about earlier. The only thing about this is it doesn't carry passengers, but it is the technology core on which we are building vehicles that will carry passengers. This flew last year at Pax River. DARPA recently decided that the movement that Uber is leading into commercial systems is so powerful and so compelling that they're redirecting some of their military work into the commercial side. And so this is an exciting prototype of what these things will look like. This is a configuration that we showed last year of a quarter scale, what something might look like. But again, the point is not so much what the airplane looks like, it's what the certifiable autonomy system that sits underneath it looks like that will enable all of tomorrow's aircraft. This is another view of that system, that configuration that we showed a year ago. This is another possible configuration that these things might take. This is another configuration that they might take. There's, as was mentioned earlier, there's a lot of trade studies going on. They're very closely tied to the requirements, but taking the human out of the cockpit and making these certifiable autonomous operations is absolutely key to the economics. I know there were some numbers put up this morning that showed you could have an economic model that worked with a pilot on it. I'll just say that's one place that our numbers don't necessarily agree. When we do the numbers at Boeing, we believe that the only way you can have an airplane that seats 2 or 4 people is to have none of those seats devoted to the crew. We have 2 pilots up front on a 747 with hundreds of passengers. The economics don't work if you put 1 or 2 pilots up front and there's only 1 or 2 people in the back. Autonomy is absolutely essential to getting the utilization rates, to getting the safety rates, and even if you wanted to have these things flown, remember the first chart, there's not enough pilots to do that. So the future, the key technology underlying all of this is not the shape of the airplane, it's the autonomy systems that make it possible. I mentioned earlier that the biggest news in Aurora's world was the acquisition by Boeing back in November. You know, we can't go into detail about exactly what we're doing, but I will say that we do support the schedule that's been shown here this morning of when demonstration airplanes should be available, when certification should be possible, and when rate production systems should be available. We believe in that. We're pursuing it aggressively. And our chairman and CEO, Dennis Muhlenberg, has said that publicly. This is a quote from an article, an interview he did with Bloomberg not too long ago. And I would say stay tuned. So thank you very much.